right? One of them looks like this. The other one's like a dotted one that is like much smaller, right? And the question asks you, what is the scale factor of that, right? So I'm going to go ahead and show you now how I want you to work these out. Okay, when you are trying to find the scale factor after a dilation, you're trying to figure out what got multiplied in order to get this new shape, right? 6. Okay, so if I'm looking at this particular problem, it tells you that the dotted line is after you've dilated it, right? So the big triangle is the original, dilated is the new one, right? Or the small one. So the way we're going to do this, and it's kind of hard for you to count on that sheet there. Okay, but let's pick one of these sides on each triangle to count. Obviously, the one side that we can count is going to be this flat side here, right? You can't count the other two sides because they're diagonal. But let's count that flat side right there to see what it's going to be. Like again, on there it's kind of difficult. Okay, but if you follow this end point all the way down your paper to the x-axis, what is the x value of that right there? Well, right here it's at -9, right? You look over on this side and you follow that down to the x-axis, that is at +9. That means from -9 to +9, that whole distance, if you were to count it, would be what? Would be 18. Right? So that distance there would be 18. Okay, now let's do the same exact thing and count the dilated triangle. If you count each side of this dilated triangle, if you start here, if you start here, that's going to be at -8, I believe, right? Logan, can I talk, please? The other side, that should be at -2. Right? Again, I'm only doing this right now because it's hard to count. You'll be able to count it, right? So from -8 to -2, what is that? It's going to be 6. Right? Should be 6. Okay, so I went from a length of 18 to a length of 6. So the question is, what did I multiply by to do that? Right? Well, a lot of people think 3 off the bat, but that's not it, because I'm going from the big one to the small one. 18 times 3 would not give me 6. Right? I'm working backwards here. So the easier way to do that is going to be to take the dilated shape. So take the dilation and divide that by the original. Right? So take the dilation and divide it by the original. In this case, the dilation is 6. And then the original is 18, right? So 6 divided by 18, if you put that in your calculator and you turn that into a fraction, you should get 1/3 is what you should get. Therefore, the scale factor in this case would be 1/3.
Oh, you said 6 divided by 18. No, I put 6 divided by 18. Okay, you gonna get 1, 2, 3, 3.
Right, because the fraction is 1/3.
Yeah, 1/3. I did. You know what I did? I put 6 divided by 7.
Right, so that is what you should get when you do that dilation. Again, so just find two sides to count, and you can find what the difference between them are. So now, if the scale factor is greater than 1, did it get bigger or did it get smaller?
Bigger.
It's going to get bigger, right? Anything that's greater than 1, it's going to get bigger. Anything that's less than 1, it's going to get smaller. That's why this had to be a fraction that was less than 1, right? So it got smaller. Okay? So what I want you to do today, you know you have a test tomorrow. I want you to work on these today, right? I want you to pay close attention. You will see all 4 of these things right here. You will see partitioning, constructions, dilations, and then right triangle triangle, sine, cosine, and tangent. You will see all of those.
Did we get rid of them before?
No. That's why you need to practice